We're always hearing that AI is learning. But what does that actually mean? What's happening inside that digital brain? Well, it's not just memorizing things. The truth is way, way cooler than that. See, AI doesn't just memorize data. It builds a model of the world. And if you can wrap your head around that one core idea, you'll understand how all of this technology really works. Because here's the thing, real intelligence, whether it's in you or a machine, isn't about knowing a bunch of facts. It's about building an internal representation of reality so you can actually navigate it. We do this all the time without even thinking about it, right? You see dark clouds, and your internal weather model kicks in and predicts rain. It's a shortcut, a simplified version of the real world that helps you make a good decision, like, grabbing an umbrella. AI is learning to do the exact same thing, create its own world models from the data it sees.
But that leads to the really big question. How does a computer, which just sees ones and zeros, build a complex model of the world without a programmer telling it step by step exactly what to look for? Well, it turns out there are two main paths a machine can take to learn. And the difference between them, that pretty much explains the entire AI boom we've seen over the last 10 years.
On one side, you've got traditional machine learning. This is a very human-guided process. An expert has to sit down and manually pick out all the important data points, the features, for the model to pay attention to. On the other side, you've got deep learning. This is an automatic process. It just takes in the raw data and figures out what's important all on its own. Now, this human-guided process of picking features works, but it's slow and it's limited by how good the human expert is. But here's the surprising part. What if the model could learn to find the important features all by itself?
And this is where the magic of deep learning really is. You can feed it thousands of cat pictures, just the raw pixels. The first layer learns to spot really simple things, like edges and colors. Then the next layer combines those edges and colors into basic shapes. And the layer after that combines those shapes into more complex ideas, like whiskers or ears or eyes, until finally the very top layer puts everything together into the high-level, abstract idea of a cat. It literally builds understanding layer by layer from the ground up.
Okay, so the model can build these complex ideas on its own, but how does it get them right? How does it actually get smarter and make its world model more accurate? It all comes down to a constant loop of self-correction. It's a process we call training, but you can just think of it as the model learning from its mistakes. The whole goal of training is to close the gap between what the model predicts and what is actually true. It makes a guess, checks to see how wrong it was, and then tweaks itself to make a slightly better guess the next time. Now, this is what's absolutely wild. A modern AI model can have billions of parameters. Think of them like tiny little adjustment knobs. This creates a mind-bogglingly complex, chaotic landscape of possible answers. So with all that chaos, how in the world does it find the one perfect combination of settings that gives the best results? The answer, believe it or not, is beautiful and simple. It doesn't try to solve the whole puzzle at once. The key is to just take one small, smart step at a time. This process is called gradient descent. Just imagine the model is standing on a huge, hilly landscape. The lowest point in the deepest valley represents the perfect answer, 0 error. So, from wherever it's standing, it looks around and figures out which direction is the steepest path downhill. Then, it takes one small step in that direction. It does this over and over and over millions of times, always stepping downhill, getting closer and closer until it finds the lowest possible point. It's basically an algorithm for finding the truth. So, learning from labeled examples is powerful. But what if a model could learn without a teacher at all? What if it could learn just by interacting with the world and figuring things out for itself? This is where things get really fascinating. This is called reinforcement learning. So instead of being handed the right answers, the model is dropped into an environment, like a video game or a simulation, and it's just given a goal. It learns completely through trial and error. It tries something. If that action gets it closer to the goal, it gets a reward, a little digital pat on the back. If it doesn't, it gets a penalty. It's literally learning by doing. And this changes everything. Think about it. Supervised learning is ultimately limited by human knowledge. The model can only ever be as good as the data we humans label for it. But reinforcement learning, its only limit is the environment itself. This is how DeepMind's AlphaGo beat the world's greatest Go player. It didn't study human games, it just played against itself millions of times, discovering strategies that no human had ever even thought of.
It didn't just copy our intelligence, it created something entirely new.
So we have these amazing algorithms that can learn in different ways, but every single one of them relies on one thing. And honestly, this is the part that most people miss when they talk about AI.
There's a really old saying in computer science that has never, ever been more true than it is right now. Garbage in, garbage out.
You can have the smartest, most complicated algorithm on the planet, but if you feed it bad data, you're going to get a bad model. It's that simple. On the flip side, a pretty basic algorithm that's trained on a huge, high-quality data set will almost always blow the complex one out of the water. This points to a fundamental truth of AI.
And the truth is this: the data is more important than the algorithm. You can think of the algorithm as the engine, but the data is the fuel.
And when we say good data, we're really talking about two things. First is quantity. The more data, the more experience the model has to draw from, which helps it generalize to new situations instead of just memorizing what it's seen. And second is quality. The data has to be accurate, and it has to be diverse enough to cover all the different scenarios the model's going to face in the real world. Without that, its understanding of the world is incomplete and unreliable.
Which brings us right back to the beginning. We wanted to know how AI really works. We've seen how it builds these incredible world models, how it learns from examples, and how it can even teach itself new things from scratch.
But if you only take one single thing away from all of this, let it be this. AI doesn't become intelligent because of algorithms. It becomes intelligent because of data. The data is the distilled experience of the world, and the algorithm is just the machine that compresses all of that experience into a working model of reality.
Subscribe for more simple AI explanations.